Hey everyone, in this video we're looking at index notation. So to get us started, it's just that in mathematics generally we like to shorthand things, so that's why we use symbols, numbers to represent our ideas and what we're planning to do, or expressing the mathematics that we're going to do. So the learning goal for this lesson is to use index notation to represent a number multiplied by itself. That kind of gives you a clue of what it actually is. And then success criteria, you're going to expand a number written with index notation. Alright, so just some vocabulary to start us off with. When we have a number, say 2 times 2 times 2 times 2 times 2, instead of having to say that, and sometimes because the more times you repeat something, you're more likely to mess it up. So we can actually use this shorthand here, and that is this 2 to the power of 5. Now the big number, so that's how you can remember this. This is your big number, is your base. And that means that's the number being multiplied by itself. And you can see that there, because there's 2. And we have 2 times 2 times 2 times 2 times 2. And the index indicates how many times that base is being multiplied. So that is the little number. And as I said, the little number indicates how many times it's being multiplied by itself. So we can see 5 here, and there's 1, 2, 3, 4, 5 times. So that's what those things mean. So there's the index there, just so we can link those two things together. Okay, so let's use that vocabulary that we have and apply it. Okay, so here we got a question here, writing in index notation. So we've already got the problem. It's 10 times 10 times 10 times 10, and we're being asked to write it in index notation. So I'm going to get my equal sign. I'm going to identify my base, so that's going to be 10 because it's the number being multiplied by itself. Then I'm going to count out how many 10s I have. 1, 2, 3, 4. Then I write it as a little 4 above. It's the same thing again with the 8. So I'm going to move over so I have more space. Again, 8 is our base because it's the number being multiplied by itself. And I have 1, 2, 3, 4, 5, 6 of them. So it's to the power of 6, or the index of 6. Then this one here and this one is a little bit trickier. However, the principle is still the same. So you should be able to recognize. Let's look for the bases that are the same. So I've got 2 2s. And I've got 2 3s. So I'm going to, just to give you an idea, my base is 2 and it appears twice. So it's going to be multiplied by itself twice, or to the power of 2. And then my 3 is the base because it's been multiplied by itself, and it's 1, 2 twice. And I treat it still, and in between those two things is still the multiplication. So that's how you can write that there. So index notation isn't just limited to one base. It's can also be applied to questions like this, or even questions like this. So I'm not going to change my color on this one. It's 3 is one base, and that 3 has been multiplied by itself 4 times. My multiplication in. And I have my other base, which is 5, and that's been multiplied by itself 3 times. Now to go the other way, so these questions here are asking to write in expanded form. So here we got 11 to the power of 3. So we know that this number here is our base. So I know it's going to be 11 multiplied by itself, and this little index tells us how many times. So that's 1, 2, 3. So 1, 2, and 3. Again, with this one here, we have 5 is the base, so we're multiplying it, and the little index, the power, is telling us 2, 3, 6 times. Now this one here, think about it, 3 to the power of 5 will be 3 multiplied by itself 5 times, multiplied by 3 to the power of 3. And so 3 multiplied by itself 3 times. So if we think, like, if we expanded out this one first, then this one, I wonder how many 3's we would have. So let's have a look. 3 times 3, because we've got 5 times 3, 2, 3. And if we have a look, 1, 2, 3, 4, 5, 6, 7, 8. So that's it written down in expanded form. Hopefully by the end of this lesson, you have been able to expand a number written in index notation. That's these questions here. And you've got your you do questions here. Make sure you read which ones you have to do. Okay guys, have a good one. Bye.